Okay. Well, welcome to Nullcon, the first evening talk. I'm honored to present to you GNU Anastasis. I'm sure you're familiar with the little problem of key management and people losing keys. Now, I know you might be the people who get the keys, but you know, think of the defensive side for tonight only, right? And of course, what's the real problem? You know, you want to keep your keys available. If you lose them, that kind of sucks, right? And so if you give one person a secret, it might get lost. So what do? You give it to more than one person, right? And well, if you give many entities a secret, then it will get disclosed. We also know that one, right? So then you give them only a share, fine. And then you have the problem, okay, if I do k out of n, you know, then how do we scale this? And I'm sure you're all familiar with this, and we do use polynomials for that. You know, we can interpolate polynomials with a couple of points on the curve, and then do Lagrange interpolation to reconstruct it, right? And then, you know, okay, we have to do this on an integer field, not with real numbers. And that's where most people doing key management kind of stop, and now they've reinvented Shamir secret sharing if they haven't known it before, and great. But actually, you're solving the wrong problem, in my view. Oops. The reason is simple. We don't have a scalability problem. At least, you know, I don't have enough friends to share keys with that were able to technically run this. And if I want to do a key recovery, I don't want to talk to 10 people to get a key share, right? And even if I want to talk to 10 people out of 20, you know, well, computers these days can handle a 200,000, you know, something. So we don't have a scalability problem here. You know, for all of the practical purposes, like 20, you know. So anybody who tells me, you know, why don't you implement Shamir secret sharing? They're just on the wrong level. So we want to build a realistic key recovery system where, of course, the consumer remains in control of their key material. We don't have a trusted third party. We don't like those, right? And it needs to be usable. That's the really hard one, and flexible enough. So what's Anastasis? Well, we do split the keys across multiple service providers. Now, what's interesting is the service providers learn almost nothing about the user. So they don't, in some sense, often don't even know who their users are. And of course, only the authorized user can reconstruct the key material on their device. You know, we don't reconstruct it in the cloud and then hand it out or something silly like that. Now, to start with, the Anastasis system for privacy-preserving systems starts with something very unusual, in that it asks you for all kinds of crazy personal information. Right, so you go, this is a privacy project, and the first thing it asks me is for my name, social security number, date of birth. You know, what is this? Well, the real answer is we need to generate a user ID, right? And we basically will run this through an expensive hash function to generate a unique user ID that you hopefully will not be able to forget, you know. And then under that user ID, we will store metadata about the recovery process so we can enable the recovery later. But so this data, very important, will never leave your computer. You know, we don't store it, we don't need it in the network, we just hash it. And the more sensitive data we ask for, well, the less likely it is somebody else will ever get hold of it. Which brings me to our adversary model. We kind of have two. We have the weak adversary, you know, the cat. That doesn't know all of your details. You know, the cat doesn't know your social security number, your date of birth, and your name. Right? And in the weak adversary model, we basically can say, well, you know, you may do a couple of repeated requests to the same endpoint. We can kind of see that. And when we are the provider, we might learn, you know, what is your email address or your phone number to send you an email or a phone number. But that's it. We guarantee there's nothing else the weak adversary can do. Whereas a strong adversary who does know your user identifier can basically find out across which providers you shared your secrets. And if they convince enough providers to collaborate with them, they could actually reconstruct your secret. But of course, they have to, you know, get through all of these jurisdictions, to all of these providers, get to all of these databases, and get all of the key shares, you know, strong-arming the respective providers that you picked, and there has to be a sufficient number of them, right? But in practice, we will have quite a few weak adversaries who don't know all of this private information about you, and maybe there are some strong ones. Okay, so let's briefly look at the process. You know, usual high-level view is we have our providers on the right-hand side, and you basically do as your backup, share the keys with the respective providers together with some authentication information. Now, start with a picture show. This is our key secret, right? That's what we want to protect. And so the first thing is, well, we split it up, right? Now, then we collect this information from the user, right? Who are you? To create your user ID. And from that user ID, we will derive two keys, key 1 and key 2. And we will use the first key to encrypt each of the key shares. So that even if you have the key share, well, if you don't have key 1, it's completely useless for you. And then we will use the key shares and attach the respective recovery data to it. Like, to authenticate against this key, to get this key share, this provider is supposed to, send you a challenge to an email address, or you're supposed to answer a security question, or whatever the challenge is going to be for that key share. And then we're going to encrypt that with the second key, so that the providers who will get this information can't even see what the security challenges are. And that's what we're going to distribute to the providers. So at this stage, they learn basically really nothing about you. They say, okay, we store this blob. We can't decrypt the key because we don't have K1. We can't look at the security challenge because we don't have K2. Oh, well, we can store this, fine. And then when you want to do the recovery, you again start with your identity information, derive the two keys, and now you share the K2 with the respective providers where you decide these key shares I'm going to recover. And then the providers can find out, oh, okay, I have to do security question, or I have to send an SMS to a phone number or something like that. And when you pass the security challenge at that provider, which is the only thing they have to be trusted for, they will send back to you that key share. And, well, once you have enough key shares, well, you can use your K1 to decrypt it, and then hopefully put the whole secret back together. Now, this is the very high-level simplified version. There are a bunch of additional things, like we have policies that allow you to freely configure how you want to split your secret. So, for example, you might be a company that goes and says, okay, one of my employees, another one of my employees, each of them with 2 factors, right? Or the boss of the company, any kind of arbitrary Boolean expression you could basically make use of here. We have for the user identifiers at each provider, there's a salt, which makes sure that each provider will see a different user identifier, so they can't say, oh, we're all storing key shares of the same user here, right? So we also have a Thaler payment processing in the protocol, which I'm not going to demonstrate today, where we can basically say, okay, I want to pay for this provider to do this service, right? So the provider can say, well, to send you the SMS, please pay me $1, which has 2 effects. Once of all, we have a business model. Yeah, it's good if you want to make sure these providers are kind of reliable, right? And the second thing, it's good protection against brute force attacks, right? Even if the pin is a bit longer, maybe somebody just decides to do 100 million of these, well, send me 100 million times the challenge. Well, if you have to pay $1 every time, that's going to be very bad. Yeah, so with this prelude, I want to get to the demo. So here's our GTK client. I know you all love GTK, right? There's also a web extension version, so we have implemented the whole thing also in TypeScript, but I personally prefer GTK. It gives me more the feeling of this is actually running on my computer. So, okay, let's back up a secret. And so the first thing we're asking users is basically, where do they live? And for the demo, we live in testland, which basically goes to loopback. Don't trust the internet at conferences. But if you go to other countries, it will ask you for specific information that's, for that country in the next screen. So here in test land, everybody has a square number. In demo land, everybody has a prime number. In the United States, everybody has a social security number. In India, everybody has an ATVAR number, right? So this is kind of where this country comes in. So I'm very lazy at typing, so I'm Max Mustermann, and my square number is 1. Wonderful. So, yeah, this is not very high entropy, obviously, but so it says, okay, make sure that you remember this, because if you forget any of this, you will not get your secrets back. And now we can configure which authentication methods we want to have. We have actually support implement for 6 methods: sending you an SMS, sending you an email, security question, sending you physical mail via post office, doing a transactional time-based OTP, and IBAN. IBAN means I'm going to send you money from my bank account, because I presumably have control of my bank account. If I do that, then you can kind of trust it's me. That one doesn't work for the demo here for kind of obvious reasons, right? Well, some of them others don't work either. Here you can kind of say I want to have additional providers than what's configured by default, but let's start with something simple. Okay, whatever, me at. So what we do is we force people to add at least 2 secrets, so we can at least split it across 2 providers. So security question, I'm very uncreative. Q1, A1, sorry. What I should also mention is the answer is of course salted, so even the provider that gets the answer can't reverse back to the answer because he doesn't learn the salt in the protocol. And we include a different version of the hashed answer in the decryption process of that key share. So if you don't know the answer, you can never ever get anything out of the system. Time-based OTP is a bit more special. I have to actually start my TOTP app because it doesn't let me continue unless I type in the right code immediately. So, okay. Yeah, this one is not safe because you can kind of scan it now, I know. 8, 1, no, too late. 6, 4, 8, 5, 7, 5, 8. Okay, let's just do 3 factors enough for today. So this is where you can edit the policy. So by default, it kind of goes and says, oh, you've only configured 3, I guess I could do 2 out of 3. But you could go and say basically, okay, I find question plus TOTP, that's not a good recovery policy. Delete it. Or you could go and say, I'm going to edit this one and say you also need to answer one of these at another provider or something like this. So you can kind of freely configure here how you want the policies to look. It just suggests you a reasonably sane default. Okay, now we have to give our secret a name. The idea is you could have many secrets, right? And so if you have more than one secret, it will, during recovery, tell you, okay, you've got all of these secrets, which one do you want to recover? Right, so say name here. Great, I'm very creative tonight. And what's the good secret? Null pointer. Good. So, and there can be fees, so here it's gratis because it's the demo. You can also upload a file if you want to share your GPG keyring or something like that. Okay, that's it. So we've stored all of our shares at the data loss incorporated. Yeah, loopback, right? And if we want to do recovery, you know, it's what you would expect. You would have to again start by entering your personal details. Because I didn't restart the process, it remembers it, but that's because it's still running. If you had quit, you have to re-enter it. And now it has basically what it does, it asks all of the providers it knows, hey, do you have anything under this user ID? And the providers go and say, well, I have this blob, and then I can decrypt the metadata and find out, oh, there's a secret under the name, right? And if you had done multiple backups, you would get all of those here. So I can select the name. Now I have to solve the security challenges. Well, none of these are very easy to solve in this context. Let's do security question. Okay, so A2 was the answer, right? No. A1, fine. Now the email in this system is sent to a local file. Test, right. Okay, and here's our secret recovered. You can see it up here, null pointer, you know, or as a QR code. So that's the quick demo. Now, I should stress Anastasis is a protocol, you know, mostly a REST-based protocol with some crypto around it. The crypto is the most boring one you can imagine. We have hash functions and a little bit of symmetric encryption. Right? There's no public key crypto in there, so you know, good luck with your post-quantum attacks. We have the backend implemented in C, a GTK frontend in C, a TypeScript frontend. We have dependencies for payments on GNU Taler. For the database, we use Postgres. For banking access to FinTS, European banking system, we have libEUFin, and we use some utility functions from GNUnet and GNUnet MicroHTTP for this whole thing. If you want to try it out yourself, well, here are some installation instructions for getting Debian packages or Ubuntu packages. This is the version 0.3. We are still in the process of releasing 0.4. You saw 0.4 demo today. Okay, so that's my quick presentation. I'm happy to take any questions. But before you take questions, why am I here? We need providers. If I run a provider, that's great. But if I run 5, that's not so great, right? So I want to encourage people from the community to come to us and go and say, okay, I can run a REST server with the Postgres backend, and I can kind of not lose the data all the time. Now, if you do lose the data, hopefully it's just a key share, right? And there are other ways to recover it. So we don't have to trust you completely that you're super reliable, right? But this should be a better way to do key management than what we have so far. Okay. I'm supposed to repeat your question, so just shout it at me. Key 1 and key 2 are not really stored. They are derived. So you have a hash key derivation function that has 2 different salts, and you have the master key that is this user ID. And the user ID is itself derived from hashing all of your personal attributes. So the question is, how does this relate to the strong attackers? So a strong attacker can basically get your identity, can get your user ID, and can get K1 and K2. Right? That's why a strong attacker can find out where are your keys stored, right? But he still has to convince the providers that he passes the authentication challenge. Right? I mean, the strong attacker basically can impersonate you perfectly, except for the authentication challenges. How do we get the salt for the questions and answers? We just randomly generate 128-bit salt locally. And but when during recovery you talk about. Okay, so we have what I didn't show. We have a recovery policy document which specifies which key shares are on which provider, and together there is the which key share is where. We also would have the salt in that document, and this is where we have this metadata that also says that this is the secret with this name. And so this is what you first fetch. So once you have this user ID, there's another key that's being derived here. And that's what you use to get this recovery policy document. And that will then tell you what the key, where the key shares are and what the salts are for security question answer hashing. Yeah. Okay, so the question was, how do the authentication codes get generated? So what the system does, it has for the different authentication methods different time thresholds. So for example, it might say for an email, I'm going to generate a fresh code every half hour, right? But for physical mail, I'm only doing fresh code once a day. And it has a second limit of how often it's going to send you the email. So if you ask within 3 seconds, a second time it might not send you another email and just tell you, oh, come on, wait a little bit, be patient. But then after whatever 30 seconds, it might send you the same code a second time. But if you wait half an hour, then it will be a new code, right? And then it has for the authentication challenge, it has a window during which it accepts the older codes. It has a challenge ID, so to speak, and a time frame for which this code would be valid for somebody to come to answer it, yes. So how are data changes handled if I move or have a different mobile number was the question. Well, hopefully the answer is you didn't say you need to satisfy all factors, and maybe you remembered that you need to upload a new one, right? So if you change your phone number, well, you will not get your SMS, but maybe you can still do the OTP and physical mail address or something like that. But if you lose the ways to authenticate, well, you will not be able to recover. Maybe you can convince the respective provider with a good lawyer or something, but what you can do in advance is basically make sure you have enough secrets, enough diversity, and enough redundancy, and maybe add the ones from your wife and so on, and make a policy that says, okay, either my phone number or my wife's phone number or something like that. You can make very complicated policies here. And it's not Shamir K out of N, right? And so you can really say, okay, on my phone I get my emails and my SMS, so that's not two-factor for me. right? And you might go and say, okay, so I'm rather going to use my phone for email or SMS and my partner's phone or email SMS, right? So just pick a good policy is the answer. And what that is, of course, we can only provide limited guidance given that we don't know your personal situation. So, okay, so the question is what can I change it later? Well, the answer is you can always upload a new secret to a new set of providers and a new set of policies, right? And typically there's an expiration process, like after 5 years, the old stuff goes always away. You could pay for longer, but the idea is if it's an important secret, you should, decide, okay, I'm going to renew this, and then you can, of course, change the policies associated with that. Okay, so the question is there a way to revoke it? And the answer is no, because we decide that's also dangerous. Somebody might be able to convince us that we should stop this, and then you can't get back to your secret. So it's not clear which, revocation, is that more dangerous or more helpful? So we decided let's not do that. But, in theory, if we had a very good way of making sure that this was a valid revocation, we could, of course, delete the record from the database. But I personally think that's more dangerous than what it's worth. Yeah. How do we handle fault tolerance and human stupidity? Oh my goodness. Well, what we are trying to do, for example, when the user has to enter information, we validate it. So as you might have seen with the TOTP, I had to actually have the TOTP. We didn't just say, okay, we showed you the QR code, do you believe it? It's fine, keep going. We said, no, enter the challenge once so we know that you actually had a TOTP application, right? And the same for your social security numbers and stuff. We will do some input validation and check the checksums if there are any, right? So we do the sanity checks where we can do sanity checks on the inputs to reduce you from going, oh, I'm supposed to enter social security number 1, 2, 3, 4, 5, 6, 7, 8. I would just basically go and say no. Right, so that's the best I can offer here. Plus, of course, as I said, if you give us a certain number of secrets, we basically will not by default say, okay, you need all of them for recovery, but we will do a slightly lower threshold, whatever, 3 out of 5 or something like that, so that there's a inherent default that says, okay, you don't need to pass all the challenges because probably it's safer for you if you only pass, 3-factor than if you have 5-factor authentication. But you can override that, right? So, but we try to provide sane defaults and input validations. Well, a certain level of intelligence is always required. Right. I think this is still way more usable than what anything I've seen out there before, right? But I cannot say it's foolproof because we know how damn creative fools can be. We verify them in terms of the checksum if they have a checksum for the verification of social security numbers. We cannot check if this is actually your social security number. That's, usually the governments don't quite give us access to that database. Yes, that's the strong attacker model, right? If you impersonate somebody else, yes, you can do that. What is interesting though, in order to do an upload, there might be also money that has to be paid. Right, so you might basically pay for me to store my secrets, and you have to have the proof that you made the payment. So you can't just say, "Oh, Christian paid for his upload there, and now I'm going to upload a bunch of stuff under his account." You have to have the payment proof to do updates. Last row. Okay, what's the point of encrypting something with K2? The answer is simple. First of all, if the provider's database ends up on the internet, everything is still encrypted with K2. So you don't get a list of all of their users, you just get garbage. Right? So as a provider, I love everything being encrypted with K2 because it lowers my responsibility. Second point of it is, I may never do the recovery. I might have done the backup, right, to store the secret. If I didn't lose it, I don't need to ever do the recovery, which means the provider will never learn anything about me. And with privacy preserving payments, the provider may store secrets of people he will never learn who they are. Right? So the idea is you do during recovery we disclose this. But what if there is no recovery? Well, then no, they will never learn. Right? And if the provider, if it's a good provider, and we have basically an agreement draft that says, if you want to be a provider in our default list, you must guarantee that you forget K2 the moment you've used it, right? So, and the email and everything else, you know. So the assumption is that you have a very short exposure to that risk, right? Which is much better than having all of this data in clear text on your drive. The provider is receiving one of the two keys, but not the other, right? So one stays always on your system. That is the one to decrypt this secret, right? But the K2 is disclosed to the provider. The K1 stays with you locally. The question is, can providers collude with each other or not be trustworthy? In principle, yes. Of course, when we put them into the software, we will try to have a good look at them and ask them a couple of questions. But the good thing is, again, one provider failing fatally shouldn't really impact you because multiple have to fail. Yeah, if you, again, we are not looking to have 100 providers in that list, right? Well, so if one attacker has ownership of multiple providers, as I said, when we put people into that list, we will try to make sure that they are all very disjoint as much as they can be, right? I'm not looking at the very big telco providers. I'm looking, you know, I've had talks with FSF, Holland Foundation, you know, Digital Courage, you know, so they can be for profit, but I'm looking at smaller hacker organizations to do this, you know, not AT&T, you know, just kind of a bit more trustworthy operators than what you might be thinking of. And I think if FSF tells me, you know, we have nothing to do with Holland, it's probably okay. Yeah, now we are way over time, but I will be at the GNU booth together with Jose, who is here for GNU Poke, a binary editor, all day tomorrow. So I propose you ask me questions then before the organizers get very upset with me just taking all evening for questions. What do you think?